Hey guys, hey, welcome back to the most recent installment of Learning Math with Mr. Bauman from Mr. Bauman's basement. Coming right back at you, same basement, a little bit different background, same subject, still teaching you math. We're actually going to hit some skills today that we've seen already this year, but it's a huge hitter in ninth grade algebra, and that's really what I want to spend these last couple videos on, is really hitting some of those core, those fundamental skills that you've learned this year, but I know you're going to see again next year as high school freshmen, and I just want you to be as prepared as you can be. I'm confident in that if we keep practicing these skills. So we got a couple more weeks to finish strong. We're so close to the end of the school year, and I'm so appreciative of all the hard work that you guys have put into this, and your hard work will definitely pay off. If you're not seeing the payoffs yet, you soon will when you get to high school. I'm feeling comfortable and confident in the fact that you guys are prepared. You're ready to walk into that first day of high school because you've worked so hard. So keep it up. You got another couple weeks to go, but we'll get there. So we're going to jump right into it. I got a little bit different hat for you, y'all. I hope you're doing well. I hope this finds your family doing well. But I got my supplies. You're going to need your notebook. Might need a calculator. Probably not, but it wouldn't be a bad thing to have it handy. So you need your notebook, pencil, and probably a calculator. I got my supplies. I got my whiteboard. Got the marker. Got the magical eraser. And of course, no good lesson is complete without a nice, warm, this is warm, cup of joe. So, good morning. Very good. Ooh, that's good today. It's really good. Never go wrong with some Maxwell House in the morning. All right, here we go. Let's jump right into it. If you want to take out your notebook, we got a huge, as I was mentioning, huge 8th grade math skill. Solving story problems by setting up and solving systems of equations. That is a jam-packed statement right there. That is a jam-packed objective. Really no other kid in the building, no other class in the building would be able to do this. This is really bringing together lots of different skills here from 8th grade. So we're going to set up systems, but specifically we're going to set them up in order to solve a story problem. So some real life examples today, and we're going to solve these systems. Now, just to review, we've looked at 3 different ways to solve a system this year. We've graphed them, and we tried to figure out where do they cross. Most of the time they cross once. In one of your most recent videos, we saw that sometimes lines are parallel to each other, and there's no solution. Sometimes they're lying right on top of each other, and there's infinitely many solutions, but most of the times the 2 lines are kind of going in different directions, and they cross each other one time, and that's the one point of intersection, the POI that we're looking for here today. So we're not going to be graphing. We're going to be trying to solve these a little bit more efficiently using these other 2 methods that you've learned this year. Substitution and elimination are the 2 we're going to focus on here today. The 2 story problems that we're going to do here today, very similar to what I'm asking you to solve in your Google Doc. One of the last few assignments that I have for you is today's Google Doc. The 2 problems on the Google Doc are very similar to what we're going to do here today. So that's a quick review or a little overview of what we're going to be doing here today. So we're going to jump right into this first story problem. Again, guaranteed you're going to be looking at systems next year in 9th grade. You've learned it, we've practiced it, but because it's such a huge skill, I want to look at it one last time before you guys head off to high school. So here's our first story problem. If you need to pause the video, I'm going to move kind of quick through here because I know you can pause this video and get this story problem down. I'm reading backwards in my screen, so bear with me here, okay? Bear with me. It says Greg and Brad each had a water bottle. So they each have their own water bottle. They're not sharing it. They each have their own. Let's say they're out cutting grass and they're really starting to get thirsty. So they decide they're going to go find some drinking fountains, some water fountains, and fill up their bottles because they're getting so thirsty. So they each approach a fountain. Greg's bottle, as he walks up to the fountain, Greg's bottle already has 4 ounces in it. So Greg's bottle already has 4 ounces in it. And his water fountain, let's suppose he goes to like the taller water fountain, his water fountain fills at a rate of 0.25 ounces per second. So that's his, what we would consider like the fill rate, the flow rate. So his water fountain fills at a rate of 0.25 ounces per second. Brad goes up to the other drinking fountain. As Brad walks up to the fountain, he notices his bottle, as he walks up to it, is completely empty. There's 0 water in his water bottle. So he goes up to his water fountain, and he notices his is filling at a faster rate. His is filling at a rate of 0.75 ounces per second. So for whatever reason, the flow rate of the water in Brad's fountain is higher than the flow rate for Greg's fountain. Greg started with more, but his is filling slower than Brad's water fountain. Okay, again, pause the video if you need to get all this information. X, we're going to let represent the number of seconds that goes by as these two guys are filling their water bottle. Y is the number of ounces in the water bottle. So Y is the output, or the range value. X is the input, or the domain value. Those are important pieces of information as we tackle this story problem. Let me clear some space up on my board. So one of the first things I'm going to ask you to do tonight, and these story problems will kind of be laid out for you in the document as text. What I want you to do, obviously, is the math behind it. So part A today in your Google Doc, I'm simply going to ask, what are the equations in slope-intercept form that can be used to represent both Greg and Brad? So they each have their own equation in slope-intercept form. What you might be wondering, well, why is he using slope-intercept form? It's because we have a starting point for each of these guys, and we also have a rate or a slope for each of these guys. The flow rate is the slope. So Greg's equation in slope-intercept form would be y equals what? What is his slope? What is his rate? His rate was the slower one, 0.25. So Greg's equation would be 0.25x. What is his starting point? Greg started with 4 ounces. So Greg's starting point, his value of B, is 4. So there would be Greg's equation in slope-intercept form. Brad, on the other hand, his is also in slope-intercept form, but his slope was higher. In fact, it was 3 times higher. His was 0.75x. What was his starting point? How much water did he start with? That's right, he started with 0. You can put a plus 0 right here, but it's kind of unnecessary. Okay, that's part A. I just simply want you to come up with the equations for the 2 individuals in your Google Doc. Part B, I'm going to ask, what would this system look like? So if we kind of transform this into a system uses braces. Remember doing this? All you have to do is move your equations into this brace to create a system. So our system would be, with the brace, both of these equations simply filled in to a brace. There's part B on your Google Doc. It also asks you in part B to solve it. So I want to try to solve this system. Now, because they're both in slope-intercept form, substitution is going to be a really good choice. So tonight, if you have 2 equations, or today, if you have 2 equations in slope-intercept form, my suggestion would be use substitution. Now you might be thinking, gosh, good gravy, Mr. Bauman. It's been a long time since we looked at substitution. That's why we're reviewing it today. All right? So substitution, this is like we pretended like we were playing basketball. You had the sub and you had the starter, and you had to yank the starter, put in the sub, substitute them in, right? So essentially, because both of these equations are equal to y, I can plug 1 in for y. It doesn't matter which way I go because they're both equal to y. I'm going to take this one and substitute it in right there. So I'm going to take 0.75x, put it in right there. You like that sound effect? Put it in right there. All right, so let's do that. 0.75x equals 0.25x plus 4. Now, partner, we're really close. We now have an equation. Y is gone because we substituted in. So now just solve it for x. Take away 0.25x from both sides because of the teeter-totter effect that we talked about in 7th grade. So we get 0.5x equals 4. This is where a calculator can come in handy. 0.5 is really 1/2. So I could multiply both sides by the reciprocal or just divide by 0.5 on your calculator. And we get x is equal to 8. I hope you got 8. I got 8. I hope that's right. I think it is. We could check it here at the end. We could check it. But this is 8 what? What does x represent? That was on the very first board that I showed you. X, right here at the bottom, x represents the number of seconds. That's right. So this is 8 seconds. And if I want to figure out the corresponding value of y, I could plug it in for either Greg's equation or I could plug it in for Brad's equation. It doesn't matter because they're both part of the same system. So let's plug it in for, let's do Greg's equation. So Greg was 0.25x plus 4. So I'm just trying to figure out the corresponding value of y, because right now I only know x, but I need to get y. So plug in 8 for x. Again, this is where a calculator really comes in handy. 0.25, that would be of 8. That's a fourth of 8. That's 2. So this is really 2 plus 4. So y is equal to 6. This is 6 what? 6 ounces. That's right. Y represents the number of ounces. So our ordered pair, which we call in algebra, which you will call next year in algebra, guaranteed you're going to see this again next year. We always write it as an ordered pair, x, comma, y. So part C of your homework tonight, I want to know, what does this ordered pair really mean? In words, describe what this ordered pair, this solution really means. This is 8 seconds. So at 8 seconds, both guys had what? At 8 seconds, both guys had 6 ounces. That's right. So for a split second, at exactly 8 seconds, boom, like that, both of them had exactly 6 ounces of water. What happened after the 8th second? Then the guy with the shorter water bottle, or the less water, overpassed or surpassed the person that started with more. I think Brad at that point would then have more than Greg. Okay, so that's what the solution really means. It represents something. It has value to it. This is 8 seconds, 6 ounces. You don't have to graph tonight, but I do, in the last part of the problem, want you to describe in words, what does the x mean, what does the y mean. All right, questions on that? Make sure you email me with any questions. Be happy to help you out. All right, let's move on to the second and final story problem. I told you there's only 2. This one, on the other hand, we're not going to use substitution. We're actually going to use my favorite method, and most of yours when we did this back in like December, and that is elimination. So as I write this one down, be thinking elimination in your head. Again, it's been a few months, but that's why we're practicing it here, to kind of transition you into 9th grade algebra. So when you get to the 9th grade algebra class and the teacher's like, all right, we're going to start this new thing called systems. And you're hopefully going to be sitting in your desk thinking, It's not new. I learned it last year in Mr. Bauman's class. I reviewed it again at the end of April, and you're going to be rock solid, ready to go. So let's look at the same two guys. Let's go Greg and Brad. Greg and Brad, actually two of my brothers. That's why I'm using the names. First two names that came into my head. Greg and Brad. And let's suppose they go into like a gas station, a convenience store, and they're picking up some candy. Okay, they're picking up some candy for their kids. And let X represent, bear with me a second, I didn't have this one written out. So they walk into the gas station and they decide to buy some candy. There's only two types of candy that they bought. The first type of candy that they bought is a Hershey bar. And they just didn't buy one, they bought a whole bunch. And I'm going to tell you in just a second how many of each candy that each guy bought. So let's suppose that they walk in, they buy some Hershey bars. X represents the price of one Hershey bar. One Hershey bar is X dollars. We don't know what that is. That's what we're trying to figure out. And we're going to let Y represent the price of one bag of peanut M&Ms. Y is going to represent the price of one bag of peanut M&Ms. That's the value of Y. We don't know what that is. That's what we're trying to solve for. Okay, so we're trying to figure out ultimately how much is it for one Hershey bar, how much is it for one bag of peanut M&Ms. Pause your video if you need to. Get this down, because I'm going to keep moving forward. Alright, we need a little bit more information, obviously, in order to figure out the price of one Hershey bar and one bag of peanut M&Ms. Let's suppose Greg bought 4 Hershey bars and 2 bags of M&Ms. And he spent $5. Alright, here's the next piece of information that's crucial in order to solve this problem. Greg went in, he bought 4 Hershey bars, and he bought 2 bags of peanut M&Ms. He spent a total of $5. We're not going to consider tax for this problem. In reality, yes, you'd obviously have to pay tax, but for this problem, let's just go straight price of candy. No tax considered here. Same on your Google Doc tonight. Don't worry about tax. Just straight up candy price. He spent $5. Pause your video. Alright, Brad, on the other hand, he walked into the convenience store and he bought 1 Hershey bar and 3 bags of M&Ms. He also spent his own $5. So Brad bought 1 Hershey bar, 3 bags of M&Ms, and he also spent $5. Pause your video. A little parched here. Ah, that tastes good. That tastes good. Alright, let me get some space here on my own board. Alright, part A, I'd simply want you to write an equation for each of these guys. Spilled some coffee on my board. Give me a second. There we go. Just dried off on the couch. Alright, so let's write an equation for Greg. This one's not going to be in slope-intercept form. This one's actually going to be in standard form. And I'll write it up here just to remind you. And I think I put it on the Google Doc as well to remind you. Standard form looks like this. AX plus BY is equal to C. Again, big hitter from 8th grade. Guaranteed you're going to see it in 9th grade algebra. That's a guarantee. It looks like this. Why are we not using slope-intercept form? Well, it's because nothing is growing or decaying. There's no rate we're talking about here. There's no like constant increase or constant decrease. We're simply comparing the two different prices. We're comparing the price of Hershey's to the price of M&M's. So anytime you're doing like a side-by-side comparison of two unknowns, standard form generally is going to be the way to go. All right, so Greg's equation in standard form, he bought four Hershey bars. I'm going to drop it down a little bit. 4 Hershey bars. So how would I represent that? It's 4x. That's right, because I don't know the price of a Hershey bar. So 4 Hershey bars at X dollars each, plus 2 bags of M&M's, and he spent, that equals $5. So some combination of price and price gets him $5. Brad, now that you've seen Greg's, Brad should move pretty quick. Technically it's 1x, but we don't need to put the little 1 in front of the x. It's implied. If there is no number, if there's no coefficient, we can imply that that's a 1 right here. So this would be 1x plus 3 peanut M&Ms, also was $5. Again, pause the video. All right, now you can start to tell why substitution is probably not the best idea here, because neither one of these is solved for x or solved for y. Anytime x's are lined up or stacked on top of each other, the y's are stacked on top of each other, and the constants are stacked on top of each other, that's the general rule of thumb that elimination is going to be your best bet. So let's use elimination. Part B, I simply ask you to write it as a system. So literally, you just have to put the brace in that now collects this as one problem instead of 2 separate equations. It's now, because of this brace, it becomes one system. And to eliminate, keep in mind, we want to find between 4 and 1 and between 2 and 3, which pair has the lowest, least common multiple, the LCM. This is not Larry, Curly, and Moe, as much as I enjoy the Three Stooges. This is not Larry, Curly, Moe. This is least common multiple. So between 4 and 1, what's the LCM? That's right, it's 4. What's the LCM of 2 and 3? It's slightly bigger, it's 6. So generally, you want to work with the smaller LCM. So if this is a positive 4, what do you want this to be? That's right. You want it to be its opposite. And in algebra, we call that the additive inverse. What's the opposite or additive inverse of 4? It's negative 4. So we're going to multiply everything in the equation by negative 4. Remember doing this? Taking a walk down memory lane, put yourself on the Wayback Machine. We're back in December of 2019. You're trying to make this negative 4. But in order to do that, you got to multiply everything in this bottom equation by negative 4. All right, so let's try it. Top equation, I didn't touch, right? I didn't do anything to it. The bottom equation, you got to start multiplying everything by negative 4. And I got that. Go ahead and pause the video. We're you guys smell that? It smells like the end of the problem. We're almost there. We are so close. These guys cancel. Draw a big line, big old plus sign right there. Now just start adding straight down. These guys canceled. What's 2y minus 12y? If you had 2 yo-yos and someone steals 12 of your yo-yos, you have negative 10 yo-yos. And then the constants, oh, just hit myself in the hat. The constants over here, if you had 5, take away 20, that's negative 15. Now between the negative 10 and the y, what symbol do you have? That's right, it's multiplication. The only way to undo multiplication is division. But you got to do it on both sides. You can't teeter without tottering. These cancel. y is equal to a negative over a negative. That's a positive. 15 over 10, that's 3 over 2, which, oh my stars, good gravy. That's 1.5. What does that mean? It means I almost ran out of room here. But it means it's $1.50. Hope you can read that. That's $1.50 is equal to y. Remember, y was the value of the M&Ms. That's right. So a bag of M&Ms must have cost $1.50. Now, how do we get the value of x? Plug it back in. Does it matter which equation we plug it into? No, because they're both, Greg and Brad's equation are both part of the same system. So let's go ahead and plug it in. Doesn't matter which one you do. I'm going to go ahead and do it into the bottom one, just because the numbers are slightly lower. So in Brad's equation, which was x plus 3y equals 5, I now know that y is $1.50. Do a little PEMDAS here. You got to multiply first. You get x plus 4.5 equals 5. That's like 6th, 7th grade math here, like pre-algebra. Take away 4.5 from both sides. Can't teeter without tottering. Those cancel and we get x is equal to 50 cents. What does that mean? That means if I now write this as an ordered pair, that would be 0.5 comma 1.5. That's my x, that's my y. If I had graphed this, problem, I would guarantee that these two lines would cross at this one point, this point of intersection, 0.5 comma 1.5. But we didn't graph. In the last question, I'm going to ask you, what does this answer mean? What does this ordered pair mean? This ordered pair, 0.5 comma 1.5, tell me, what does it mean? X is the price of the Hershey bar. So in the last problem, you would say one Hershey bar is 50 cents. And the bag of peanut M&Ms is $1.50. So the last problem, I really just want you to explain it, like describe what is the value of x. What does it mean in terms of Greg and Brad walking into that gas station? What does the value of y mean as well? So this would be x, this one would be y. All right. At this point, I am really thirsty. That's a nice cup of coffee right there. Y'all, like the cowboy hat? Got this in Texas, actually. Fort Worth, Texas. All right, I'm going to go upstairs, get something to eat, get some grub. But really appreciate you watching the video here today. Again, my goal here in the last couple videos is to really recap some of those really major standards, systems of equations being one of them, from 8th grade, knowing full well that you're going to see these again in 9th grade. Really appreciate you guys' work, your effort, your time, your energy on all these assignments, watching these videos. I hope you find them helpful, and I hope you're really starting to see the fruits of your labor. You know, kind of the payoff, so to speak. If you're not quite seeing it yet, be patient. You'll start to see it definitely when you get to high school, which, believe it or not, oh my gosh, good gravy. That's only a couple months away. So have a wonderful day. Be kind to one another, as always. I know we're living in some very abnormal times. Kindness really goes a long way. Be patient with one another, especially your family. Be really patient with them. And above all, as always, make sure you pray. Praying is the perfect form of peace. Pray for your family, pray for your friends, your classmates, your school, our country, and our world. We all need it, so continue to pray. Thanks so much for watching this video. Have a fantastic afternoon, and we'll catch you guys later.